Welcome to another episode of the Mapscaping podcast. My name is Daniel and this is a podcast for the geospatial community. So as the name of this episode suggests, today we're talking about PYGEOAPI. So just in case you've never heard of PYGEOAPI, it is a Python implementation of the OGC API suite of standards. But I'll let Tom Kralidis explain more about it in just a second. Check out the show notes of this episode. I'll have a few interesting links in it to some other relevant podcast episodes and to a few of the other tools that we talk about. Okay, let's dive in. Hi Tom, welcome to the podcast. So you are the creator, founder of something called PYGEOAPI, and you're also the chair of the steering committee. Would you mind just introducing yourself briefly to the audience, please? Maybe telling us how you got involved in geospatial, and then we'll move on and hopefully discover what PYGEOAPI is.
Great. Thank you, Daniel. Thank you for having me on Mapscaping. So yeah, I'm Tom Kralidis, and I'm a longtime contributor to free and open source software, geospatial software, as well as open and international standards. My educational background is I have a master's in geographic information systems, specializing in spatial data infrastructure. My undergrad was in geography, so I've always had a background in geography and maps one way or another. My entry point into the industry was working here in Canada at Natural Resources Canada, which is our national mapping agency, getting involved on the remote sensing front. And from there, I started working on spatial data infrastructure, web services, standards, and software.
Right, okay. And like I said in the introduction, you're the creator, founder of something called PYGEOAPI.
Yes.
What does that have to do with spatial data infrastructure?
So PYGEOAPI is a OGC API software implementation. It's a server which provides discovery, access, visualization, and processing capabilities for geospatial data. So within a spatial data infrastructure, PYGEOAPI is sort of a data service provider as opposed to a client or some other type of service inside an SDI. So for providing data through an API, that's the role of PYGEOAPI in a spatial data infrastructure concept.
Okay, so the skeptic would listen to that and think, well, don't we have three of those already? Like I can think of a couple here: Geoserver, Map Server, QGIS Server. There's something called Map Proxy. Like on the face of it, it sounds like these things all do the same stuff. What is different about PYGEOAPI?
That's a good point. We do have a number of different software in the open source ecosystem that do provide web services, such as the tools that you mentioned. There's also a Degree and also other pieces of software. So, which I think is a good thing from a free and open source perspective, to be able to give users choices depending on their requirements and what their use cases or workflows are. From a PYGEOAPI perspective, I think the value proposition is that you can run it in a standalone or embedded mode. That means you can use the software directly out of the box and use it to render your maps or features, provide your geospatial data, or you can embed it into your application. If you have a custom application and you want to use PYGEOAPI as sort of a library, you can plug it in to your custom application, which has all your business logic and all your dedicated workflows and custom software. And if you need that sort of spatial data infrastructure web service API thing, PYGEOAPI can satisfy that, and it plugs into what your organization is already doing. I would also add that PYGEOAPI is built on an extensible plugin framework. So the way it was architected is that there's a core to the project, a certain core to the project and the software. And then in that core exists a plugin infrastructure. And the plugins basically allow Python programmers or developers to write their own custom code, for example, to connect to data or to create custom processes. And the value of that is that while some pieces of software have very clean and dedicated connections to well-known data formats and databases and so on, there are situations where we have bespoke data formats or custom database connections or other types of processes, which they all try to do the same thing, but there's very small nuances depending on what the organization wants to do. So PYGEOAPI allows a Python developer to write their own plugin and connect to that custom data binding. So if you have a database with a number of different joins, or you wanted to rename some fields, or if you have some data format in your organization which is not recognized by free and open source tooling already, like GDAL or OGR for that matter, you can use PyGeoAPI to write a custom data binding, if you will. And by writing that plugin, then PyGeoAPI lets you plug that in to the tool, and PyGeoAPI will take care of the rest, which means doing all the OGC API standards-based requests and responses to get data, discover data, process data, make maps, and so on. So you can do that from the perspective of connecting to custom data via PyGeoAPI, or creating custom processes, which may be running through your organization, or creating new output formats that are maybe specialized for a specific community. For me, the value proposition of PyGeoAPI is the plugin capability. As I mentioned before, we do support a core set of plugins and a core software capability, but most of the value, I think, in the project is allowing users and developers to create their own plugins, which allows them to tailor things exactly how they want without necessarily having to be in the PyGeoAPI core itself. So there's an ecosystem, a growing ecosystem of these PyGeoAPI plugins out there, which they're all allowed to live on their own and move along with the software accordingly. So it's that kind of flexibility and lends itself to basically distributed software development and implementation while keeping a consistent and stable core.
Okay, so I'm not a Python developer myself, or at least I haven't been for quite some time now. So help me understand this. Does this mean that I can just write a function and have it return something and then push that into PyGeo API?
Exactly. So if you have a function that works in your organization to run some very specific statistical analysis on some data, you would write that function as a Python developer. You would write that function in PyGeo API using the PyGeo API plugin framework. So there's a few, to be able to support a plugin architecture, there are some rules that need to be followed and some contracts that need to be adhered to by your plugin as the Python developer. So for example, you could write that statistical process and you would return, let's say, some sort of GeoJSON or CSV. And as long as you send that back, you can do whatever you need to in between to generate the output, to generate the result. And then you're basically sending that back to the PyGeo API core, and it will take care of the rest for you. So you can take care of all the business logic that needs to happen in the middle, which may be specific to your organization or your project. And as long as it satisfies sort of the interface, if you will, that PyGeo API is looking for, then the rest is relatively clear cut.
So when I think about maybe creating custom functionality, so I could expose something that like created watersheds on the fly via a WMS service, as an example. Am I understanding this correctly?
You got it. So what would that look like in PyGeo API? Maybe it would be valuable if we walk through that. If we wanted to create custom maps based on dynamically creating watersheds, then Python developer would write a plugin for a map in PyGeo API, and the PyGeo API, basically the request and response lifecycle, PyGeo API would receive the request for a map with very specific parameters, such as the area of interest and the width and the height, and which data set or collection the user is looking for. And then PyGeo API would receive those parameters, send that to the plugin, and then the plugin via the Python developer is basically generating those dynamic watersheds and returning, let's say, a GeoJSON or an image of that GeoJSON back to the PyGeo API core. Then the PyGeo API core will take that output, because that's the contract between Python developer and the PyGeo API core, and it would return that back to the client, who's not aware of dynamically generated watersheds or any tooling underneath. From the client perspective, all they are seeing is that they did an API request for a map and they received an API response for that same map.
Thank you very much. I appreciate you walking us through that. Can you tell me a little bit about like the kinds of backends that I can connect to, the kinds of data formats that are supported by PyGeo API?
Sure. So we have a number of different onboard plugins that exist in PyGeo API. Probably one of the most popular one is we have a GDAL plugin, which allows users to connect to any format that is supported by GDAL or OGR for that matter. So that's quite a popular one for obvious reason. That gives you access to hundreds of formats out of the box. We also have dedicated plugins for Elasticsearch, which is a backend sort of NoSQL database, We have a dedicated plugin for Postgres, which in theory, you can use the GDAL and OGR plugin to do those, but there are some nuances for those Elasticsearch and Postgres backends, which are a little special, if you will, and allow a little bit more flexibility for the Python developer or the user to use that onboard plugin to be able to set that up and make it work accordingly. So let me just clarify that the onboard plugins that PyGeoAPI provides, you do not need to be a Python developer to add those to your configuration. You simply need to set up the service and connect to the right plugin. So from a feature data or vector data perspective, we have those types of backends or plugins. From a metadata perspective, we do have an Elasticsearch plugin, so allowing you to do searches and queries based on metadata. From a raster data perspective, we have a Rasterio backend, and we also have an Xarray backend, which is an increasingly popular library for dealing with large multi-dimensional data. And those are core sort of data format plugins. We also have other plugins to generate new and custom formats, such as CSV, as well as running bespoke processes. So that's a bit of a picture of our onboard plugins in the project. Again, you don't need to know very much about Python to use those, but they serve as onboard plugins for people that are able to use those. And they also serve as valuable examples for the Python developer who wants to develop their own custom PyGeoAPI plugin.
So you talked about these onboard plugins. Is this some kind of registry? In the same way we know the registry for plugins for QGIS or Geoserver, as an example?
In the PyGeoAPI core, they are on board. So there is an internal registry of these plugins. In the PyGeoAPI documentation, we do have an online registry of plugins that are available for other developers. And there's a number of different plugins that exist for features and for processes for that matter. So currently, I mean, they're not quite set up in a way that you can search for these plugins and install them into your PyGeoAPI environment. That could be something that we can look at in the future. But there is a web page on our PyGeoAPI documentation which shows all of the known PyGeoAPI plugins that exist out there in the wild.
So it sounds like a really flexible system. You talked about plugins or implement like access to these different backends. But of course, with custom plugins, I can also create my own functionality. In general, should people be thinking about PyGeo API as the one doing all the heavy lifting, or is this like a piece of middleware where we can attach several different backends?
That's a good question. One way to look at that would be to consider where the heavy lifting is. If you have a very data heavy process and you need to do a significant amount of calculation to be able to generate data, I mean, that's heavy. And that's where the Python developer rolls up their sleeves and writes that plugin. On the other side, what PyGeo API does give you as a Python developer writing that plugin is that it does the rest for you. So it takes care of all the standards based and compliance, OGC API compliance for that. And that in and of itself is a relatively heavy lift. So as a Python developer, you do not have to worry about how your OGC API server via PyGeo API is behaving. It's already compliant and it already implements all the standards that it supports. So you don't need to worry about any of that OGC API, HTTP request and response machinery. PyGeo API is taking care of all of that for you to ensure that the data that you provide through your PyGeo API instance supports all of the OGC API standards, and it does so in a standards-based and compliant way, which is in support of and feeds interoperability.
Okay, so it sounds like a lot of the boilerplate stuff is written for me in terms of the Python development. I guess with my last question there, I was more sort of thinking about, does this scale? Is this a cute little hobby project that I run on my server somewhere in the basement that does one very specific task, or is this something that's going to scale?
We've seen cases of both. In a lot of projects, I've seen PyGeo API as a relatively standalone microservice for, let's say, one or two data sets. On the other side, with my work with the Meteorological Service of Canada, we use PyGeo API to deploy thousands of layers or thousands of data sets through PyGeo API that is capable of serving millions of hits per day to users for that matter. So there is something to be said around scaling PyGeo API. I mean, you can install the software. It's available on a number of different distribution channels. and there's a number of different ways to install it. It is cloud capable for those that are into cloud, and you can also install it on premises for that matter. But from a scalability perspective, it allows you to scale things accordingly, according to your requirements.
Thank you very much for that. I know from a previous conversation that it's not just plugins around data bindings and custom processes, but you also have visualization plugins. Can you talk us through that, please?
Sure. So our visualization plugins are basically in support of the OGC API maps standard. So this is a draft standard from OGC, which is basically going to be the successor to the Web Map Service standard or the WMS standard. So some recent work that we did with regards to visualization in PyGeoAPI is adding support for OGC API maps. And we implemented a core functionality around that, which basically implements the specification. And for the users, we implemented a couple of backends or plugins which are on board in PyGeoAPI. One of them is using the map server tool to render maps natively. And the other one provides what we're calling a WMS facade. So a common use case for those who would like to migrate from the first generation OGC standards, such as Web Map Service or Web Feature Service or Web Coverage Service, is writing these facades or writing these bridges and having them available so that you can support both users who are tied to first generation APIs or web services, as well as those who want to move on to the evolving OGC API ecosystem. So what a WMS facade is in the PyGeoAPI sense is that a user can make a request to PyGeoAPI using OGC API maps. PyGeoAPI will take that OGC API maps request and translate it into a WMS request and connect to your WMS server, make the request in the WMS language, and return the response to the OGC API maps user as if they didn't have to interact with WMS at all. So there are a few bridges in PyGeoAPI to do that. Another one is with Web Feature Service, which is for access as well. So we have sort of a facade which through GDAL and OGR, which allows the user to talk to the OGC API features, and in the back it would be talking to a WFS server, for example. So just to recap, we do have this element of facades in PyGeoAPI, which I think will be valuable as we move forward regarding the evolution of moving on to these OGC APIs in the future, while still trying to support legacy or existing implementations.
I just want to make sure I've understood this. Are we talking about two separate APIs here, or just one API that can also accept requests as an OGC standard?
That's a good question. I would say, well, PyGeoAPI is not going to support WMS for that matter, or WFS, or any of the first generation OGC standards. It supports the OGC API ecosystem, which is the current effort in OGC to modernize all of the APIs. So it speaks that language, but it will provide bridges for organizations who want to put a modernized API in front of their first generation OGC, WMS, WFS, and so on.
Okay, I think, wow, that sounds like a really smart way of starting the migration process. My original question was around visualization plugins. Isn't there something where you can build a template and sort of alter the look, the feel of the data if I connect to the API via a browser?
Right. So one thing that we should make clear is that in the new OGC APIs, HTML is supported. So in the first generation OGC web services, primarily the response formats were XML. In the new OGC API world, the responses can be are primarily JSON. That's what we're seeing currently. So that can be GeoJSON or coverage JSON or some other dialect. They can also be, for example, gridded data, binary data formats for that matter. However, HTML is also supported. So that means you can interact with an OGC API and PyGeo API for that matter, and interact with a web page while still interacting with the API. So PyGeo API does support a web page or a website capability. So you can go to a PyGeo API install and basically interact with a web-based tool that has a very default look and feel. The other extensibility that we allow through that facet of PyGeo API is allowing a web developer to create their own custom templates, custom JavaScript, and custom CSS. which would allow for a custom look and feel depending on your organization's requirements.
So my guess is this would also be great for that quick sort of visual test, like is things working? Does the data look the way I'm expecting? Is the API working without like involving another piece of software?
Exactly. It's a very easy way to eyeball your data, as you publish it to an API. So you can, when you interact with the PyGeo API web interface, you can visualize sort of a footprint of your data set and see where, what the minimum bounding rectangle or bounding box is of that data and where it is located, let's say, on the planet. And then as you start interacting with that data, you can start to see it on a map live. So whether you have a data set of points of, let's say, monitoring locations, doing water quality monitoring, or you have base maps, or you have some other type of forecast data, you can see that data through the default PyGeo API website, and you can extend even the HTML and JavaScript as you wish.
So I realized you said before that the support in PyGeo API is focused on the next generation of standards. Can I use the first generation of OGC standards as a backend? Like, could I create services based on cascading WMS or WFS services?
Yes, that's exactly what this facade concept that we discussed earlier is all about. So you can basically have put a PyGeo API installation in front of your first generation OGC web service capabilities. So again, that's very valuable from a change management perspective, because a lot of organizations, while the OGC API effort is very innovative and a lot of people are moving toward it, there are still users who are using the first generation OGC web services, and there will be for quite some time. So we need to be able to have some sort of change management and migration pattern out there in the spatial data infrastructure ecosystem, because we can't just turn these things off, without consultation and making sure users are migrated accordingly.
Yeah, I realize that question sounds a bit clumsy, given that you've just explained that to me, but I guess I just wasn't in the mindset of thinking that this could be an external service that I could put this PyGeo API in front of and use it almost like a proxy to convert that external first generation service into a newer service. I was more thinking like, okay, if I was already if I already had some first generation services that I'd created through PyGeo API, I could just add an extra parameter and have some sort of facade in front of them. But you're saying I can point at an external service, run it through PyGeo API, and then create a second generation service on the other side of that.
Yep, exactly.
I have worked with a tool before called Map Proxy, and like given that this was some years ago, but it was amazing. You could take external services and you could reproject them on the fly. You could take multiple external services and push them together into one service. It was incredible. Is that kind of capabilities, is that built into PyGeo API, or is this something, if I wanted to do that, that I would have to create custom plugins?
Good question. So map proxy is basically a map accelerator which caches WMSs and other map-based services to provide, very responsive maps to users. A number of organizations do implement map proxy to provide very fast maps. The nature of something like WMS is such that any arbitrary request can be made to a WMS service. So by doing that, that executes a lot of machinery on the other side. And that's where map proxy really excels, is that it kind of refactors all that and puts it into a caching sort of mechanism to make these fast and responsive maps. In the PyGeo API ecosystem, and more so the OGC API ecosystem, the response to that kind of pattern is the OGC API tile standard, which will allow you to interact with a server that will provide a tile matrix to you. And that facilitates known tile sets and known tile matrices, which results in users making smarter requests for faster maps. PyGeo API does implement the OGC API tiles specification, and it does that by primarily connecting to a set of static tiles underneath. So the idea there is that for OGC API tile support, a user would basically generate static tiles on their system and then connect PyGeo API to those static tiles and provide them through OGC API tiles. Having said that, there is discussion from a plugin perspective to be able to build those tiles dynamically and seed those tiles dynamically. So when somebody is making an OGC API tiles request, you could envision a situation where I can have a custom plugin which sees my tiles on demand. So basically, if a user makes a request to PyGeoAPI and my custom plugin receives that request, basically, I can look for the tile that's associated with the request. And if it exists on my system, I can return that. If it does not, I can cache it. And then for the next time around, I can return that cached tile for the life of that tile for that matter. And the beauty of that is that we can accomplish that not only in OGC API tiles, but given the plugin mechanism by GeoAPI, we can do that for any of the APIs. So we can start to think about accelerated OGC API feature services or accelerated OGC API coverages services. So while tiles is very fixed on basically an accelerated mapping approach, we can use the PyGeoAPI plugin approach to build these caching mechanisms and seeding these caches on demand for any OGC API.
Wow, this sounds like that'll open up a lot of really interesting possibilities. We're talking about OGC standards. I'm not sure if Stack is an OGC standard yet. Do you know?
It's not. Stack breaks down into two types of standards. One is for the encoding, so how you encode a stack item or how you describe a stack item, as well as a stack catalog and a stack collection. Stack also provides an interface standard, which is called Stack API. So currently, those are not formal OGC standards. However, they are closely tied with the OGC API current ecosystem of standards. So, for example, Stack API does implement OGC API features, and the OGC API ecosystem could support Stack representations for that matter. So I think it's complementary with what's going on in OGC API. I don't have the latest and greatest information on what the future holds with regard to making Stack an official OGC, the Stack suite of APIs or encodings, official OGC specifications. I think there's some discussion on Stack API itself, but given the fact that they're based on the same underlying standards, there is a lot of cross pollination between those groups. And Stack is an important part of our ecosystem for discovering assets and especially working with Earth observation data.
Exactly. So this is a brilliant segue. This is where I was going. Can I implement the Stack catalog through PyGeoAPI?
You can, and that is because PyGeoAPI also implements Stack. So the basic idea around implementing Stack in PyGeoAPI is that you would point PyGeoAPI to a file system with your geospatial data files on your file system, and PyGeoAPI would basically turn that into an online Stack catalog. So as a user traverses down the various Stack catalogs and directories and so on, they're able to see descriptions of those files. When you click on, let's say, a Stack item, you will get a web page with that item, and it'll give you a bounding box, and it'll show you all of the properties of that item, what the bounding box of that item is, what maybe the date time associated with that item is, and so on. And underneath, it's using GDAL and OGR, basically inspecting those files, providing high-level metadata information about those files, and then turning those into a Stack item dynamically. So we do support that concept in PyGeoAPI. We're also supporting the idea of connecting to object storage to achieve the same thing. So a lot of workflows are obviously on cloud, and while our default capability assumes a file system mechanism, we do have some plugins that can support connecting to object storage and basically accomplishing the same thing. So that sort of ties into the discussion earlier around PyGeoAPI being able to work in an on-premises environment as well as being cloud capable to work in a cloud native environment.
I've just got a few questions there. Will that catalog be updated as the directory is updated? And what if that directory holds files that are not streamable?
The answer to the first question is yes. As that directory is updated, then the Stack catalog that's available on PyGeoAPI dynamically gets updated as well. You mentioned if the files are not streamable. Basically, that what would happen is when a user sees an item, they can choose to download that item, which is basically downloading the file off of the object storage or the file system. So it does provide that capability, provided the file is there.
This is my mistake. My understanding with Stack was that it was based on these cloud native formats, and that you could have access to that via range requests And so what I was getting at there was that, okay, what if it was a shapefile, for example, that wasn't going to respond to the range request? Would it still be implemented in the stack catalog?
Good question. Yeah, it will be still implemented in the stack catalog. When you're at the point of doing HTTP range requests, I mean, PyGeoAPI stays relatively out of the way there because you can directly access that file and just implement the HTTP range check right there, and that should push through right to the web server software to support the range request. So that could be possible, for example, with cloud optimized geotiffs to be able to do that. I've also seen discussions online, I think from Paul Ramsey or somebody else, around doing cloud optimized shapefiles. So as the ecosystem for cloud optimized formats continues to grow, that's something that we support in PyGeoAPI, being able to operate in that kind of manner as well.
Whew, we have covered a lot of ground so far. I think maybe a great way of sort of rounding off this conversation would be a discussion round. So, what's next for PyGeo API? What can we look forward to seeing in the future? What are you working on now?
Okay, so PyGeoAPI started, basically to recap, we started the project in 2018. So it's been around for a good 5 years now, and it's built up quite an ecosystem of a developer community, of a user community, and a number of live deployments and implementations. So it's being used all across the planet on a number of different projects, whether it's for national governments or agencies, or whether it's for other activities. So we use PyGeo API in a lot of United Nations and World Meteorological Organization projects. We also use PyGeo API here in the Weather Service in Canada. I know that the US is the US geoplatform.gov is implemented using PyGeo API. British Geological Survey, the Euro Data Cube is running PyGeo API with actually some really cool OGC API processes that do custom Jupyter Notebook execution via Kubernetes and Papermill and so on. So there's a number of deployments out there that are using PyGeo API. So we have a rapidly growing community and ecosystem of applications, and we need to support those as a community. And supporting software is an effort. So we do have a baseline to do that. We're currently at 0.14 of the software, and we do envision a future state of a 1.0. A 1.0 release would mean that we would start to provide additional support and backward compatibility as we move forward. So right now we're pre 1.0, so we're still kind of making changes to the main branch and making releases and so on. So once we get to a future state of a 1.0, then we have to consider an additional support factor. What are we thinking of for 1.0? So the project, I think, has a rapidly growing ecosystem of implementation and developers and projects. And by doing that, we've incurred some technical debt in doing that, which I think is expected given a lot of the standards and a lot of the work that we've implemented in such a small amount of time. So there is some refactoring that needs to be done in the project, which might not be so apparent to the end user, but it will, I think, help with the sustainability of the project in and of itself. It is a long-term project, so that's why when we get to a 1.0, we will be supporting it for the long term as we move forward. Our basic approach is addressing some of that technical debt and waiting for some of the OGC API specifications to reach a 1.0 status. So there's 2 or 3 of the OGC APIs that we support in PyGeo API, which are at a 1.0 state, and that is very stable. There are some other ones which are still in draft. Within the next 6 to 12 months, some of those will become 1.0. And that's also a good time for us to start to trigger the 1.0 release train in PyGeo API itself. So from a future perspective, this is a long-term project, and it is going to be supported in the long term. It's an OGC compliant project. It's also an OSGeo approved project that was approved last year, right before Phosphor-G in Florence. So we're in it for the long haul. The value proposition is interoperability and very plug-in oriented infrastructure for the Python developer, for that matter. So that's a bit of a peek into our future plans, as well as implementing the additional features and extensions in all the OGC API specifications. So currently, for example, there's a lot of work that we're doing on implementing CRS support in OGC API features through PyGeo API. That's one piece of work, and we also will want to be supporting things through OGC API records, such as catalog harvesting and federation and other similar workflows. So the whole idea is that as the OGC API specifications evolve, we will be evolving too in PyGeoAPI while having a stable 1.0 in the near future.
Well, it doesn't sound like you're going to run out of things to do anytime soon. Tom, thank you very much for your time. I appreciate you walking me through this. I realize when you're talking to a non-developer that it might be a little bit tedious, but you did an amazing job of helping me understand what it is, what it can do, and what the future might look like. So thank you very much for that. Where can people go if they want to get their hands on it and play around with it? What can they do?
They can go to pygeoapi.io, and there they will find the website, which points you to all the source code, documentation, as well as there's a support page for if you need PyGeoAPI support or you want to interact with our online community or our mailing list. So all the information starts at pygeoapi.io. There's also a demo server there that you can interact with to kick the tires and see how it works for you or your organization. But basically, I would start off at the website, and as well, we're also on GitHub with our associated issue tracker and discussions and code for that matter.
Awesome. Thank you very much, Tom. Really, really appreciate it.
Thank you, Daniel.
So I really hope you enjoyed that episode with Tom. As always, there'll be a bunch of links in the show notes today. If you want to check out PyGeoAPI itself, that's pygeo.api.io. That would be a great place to start. In the show notes of this episode, I'll have links to Map Server, Geoserver, QGIS Server, Map Proxy, as well as something called Degree. So these are all tools mentioned during this episode, and there'll be a few links to other relevant episodes in there as well. So check them out if you're interested. Okay, that's it for me. I'll be back again next week. I hope that you take the time to join me then. Bye.